So what do you think it means to bisect something? Connect something, not quite, but you're sort of in the right area.
Something
What
with
is,
two.
say it again?
Something with two.
Something with two, very good, because bi means two, right? Okay. What is it, let's take that concept, bi means two, and then what does it mean to dissect something in biology? Take it apart. Yeah, you're gonna cut it apart, aren't you? So what do you think that means then? If we're gonna take the concept of two and cut apart,
Split it in half.
split it in half. Yeah, bisect means we're gonna cut it into two equal parts, okay? So here's our objectives are. We wanna understand how to bisect a segment and bisect an angle, what those mean, and then tomorrow you'll actually do that stuff. Always remember that congruence, I harped on this yesterday, congruence and equality are different things, right? Give me an example of things that are congruent. Somebody, what's an example of something that's congruent? Come on, name something that could be, two things that could be congruent. Shapes, good. Shapes could be congruent. Something else. What have we been talking about, maybe?
Angles.
Angles could be congruent, sure. What else? Segments could be congruent. Anything that I can draw could be congruent, right? Draw things that are geometric things, geometric objects are things that could be congruent. What are the characteristics of congruence? Mallory, remember there's two parts to being congruent. They have to have the same, what? Same shape and size, yeah, same shape and size, good. Okay, now being equal though, that's just a math thing, right? That's not a geometry thing, that's just a math thing. Give me an example of something that could be equal that maybe relates to geometry. Okay, the length of a segment, how about? So yeah, the length of a line, boy, that's pretty long. The length of a segment could be congruent. We have two segments and their lengths are equal, then, if we have two congruent segments, then their lengths are equal, right? Because the lengths are just numbers. What's one other thing we talked about that could be equal? What do you think? Alex, can you think of something that could be equal? We had lengths of segments. What else? Walter, can you think of something? No? Well, width could be, sure. Width is a measurement. That could be. Ruby, you got another idea?
The angle.
Okay, the measure of an angle, right? The measure of an angle is just like the length of a line. It's just the number that tells us how big the angle is, right? So those are things that could be equal. All right, good, you got it. Okay, so first of all, midpoint. Let's talk about midpoint. Midpoint is just a point that bisects a segment. It's going to be the exact middle point. It's just what it sounds like, right? So it bisects means splits it into two equal pieces. Okay, so we could use this concept to do something like this. Let's say we know that we've got segment AB is bisected by the midpoint M, right? So midpoint M is exactly in the middle of A and B. Okay, how could I find the length of segment AB there, do you think? Any ideas?
Any ideas? Like there are two Y's, right? So you just plug it in.
Okay, well, hold this, everyone kind of just think for yourself for just a second. I got to try to find the length of AB. Okay, Angelica, can you tell me something about this relationship here? If M is the midpoint, what could you tell me about the length of segment AM and the length of segment MB? They're congruent, sure. Yeah, the segments are congruent, aren't they? Which means their lengths are equal. Okay, so any suggestions then, Dean, what strategy? How could I maybe try to somehow, I don't have any exact measurements there, do I? There's a bunch of X's in there, so I don't really know what those measurements are. Do you have a strategy for how maybe I could somehow come up with the length of that whole segment? So, okay, what do you mean by solve them? Okay, find X. Good. How am I going to find X? What do you think? Yes, sir.
You could put them both in an equation because they equal each other.
Okay, they equal each other, sure. So there's that, and once again, what are we doing? We're taking a geometry relationship and we're turning it into an algebra equation, right? So the geometry tells us that the measure or the length of segment AM equals the length of segment MB, which gives us the algebra equation, 12x plus 3 equals 10x plus 5. So now we just shift into algebra mode, forget about the geometry, and just focus on the algebra, right? Okay, so what am I going to do here, Vanessa? What am I going to do to solve this? Okay, good. So I'm going to, very good. I see that I've got a bigger number of x's on the left than the right. So you're thinking move x's left, right? Is that what you're saying? Move the numbers the other way. So we'll subtract 3 from both sides. I could also subtract 10x from both sides. So I get 2x left on this side. I get 2 on this side. So what's x?
Go on.
1. Yeah, if I divide both sides by 2, I get x equals 1. How does that help me? Braden, what can I do with that now that I know that x equals 1? How can I find the length of that whole segment? Any suggestions? Plug it in. Sure, I can plug it in. So if I plug the x in here, I'm going to get, whoops, it didn't finish, did it? Well, we'll go back. So I could, oh, it just said solve for x. But what if we want to know what AB is? I could plug the x back in there, and I'm going to get 12 times 1 is 12 plus 3 is 15. I'm going to get the same, really all I need is one side, don't I? Because I know that if this is truly a segment bisector, whatever the length of this side is, this one has the same length, right? So 15 times 2 is 30. Good. Okay. So a segment bisector is just something that intersects a segment at its midpoint, which essentially cuts it into 2 equal pieces, 2 congruent pieces. So, there's the midpoint. This just shows us that we've got congruence, and it could be a line, could be a segment, could be a ray, could be, anything that cuts that segment into at its midpoint. Okay, other issue we want to talk about here. One other little tiny piece to this, other than the bisector part. Midpoints. So I've got 2 points here, S and P, right? We want to find the midpoint of S and P. Now think what a midpoint really means, right? A midpoint is the middle point, and therefore it has to be the middle value of x and y, doesn't it? So can anybody make a guess here? What do you think that the x coordinate of the midpoint is going to be? Trevin, what do you think? Any ideas? That's right. How'd you get that?
Difference between -3 and 5, and then x4, and then 4 plus -3 is 1.
Perfect. That's exactly how you do it, right? You just want to find the middle value, the middle x value, and then we'll do the same thing for the y values. Now, let's turn that into maybe just a simple process. What does it mean to find the middle value? Like if I asked you to find the middle value of 12 and 20, what would you do? You average them, don't you? Just add them together and divide by 2. That's it, right? That's how you do it. If we add up -3 and 5, what's -3 plus 5? 2 divided by 2? 1, right? That's it. We're just going to average them. Say, what about for the y's? What's -5 plus 11? 6 divided by 2? 3. That's it, right? So if we want to come up with a formula, all it really is just the average of the x values and the average of the y values, okay? But once again, don't think of it as a formula. You'll forget the formula. Just think of it as that concept. It's just going to be the middle or the average value of x and the average value of y. Okay, so, well, here's the example we just looked at, right? That's what we did. -3 plus 5 over 2 is just 2 over 2. -5 plus 11 is 6 over 2. So we get the answer 1, 3, right? Okay, what about this one? It seems a little tricky. What about this one? Now they're telling us that the midpoint of segment AB is M, and they're telling us the coordinates of M. One endpoint is A, and it has these coordinates. They want us to find the coordinates of B. So anybody got some thinking on that? Jeremy, you got any idea about that one? If I know that here's one endpoint, this is the middle point, or the midpoint, how can I find the other endpoint? See if you can just focus on the x value. Any ideas about what the x value might be?
1,
Why do you say 1?
because 2 is the highest number and -1 is the lowest. Wait, no.
Okay.
Okay.
Oh, no, okay, you're thinking of something else here. Give you a second, what do you think? So not 1.
3.
Almost. Get the right idea. What about this is 3? How far apart is the x value of the endpoint is -1. The x value of the midpoint is 2. How far apart are they?
2. Or, I don't.
Okay. 3 apart, okay. 3 apart. All right, so Terry, if those are 3 apart, any suggestions about where the other endpoint would have to be?
3 away from the others.
3 away from the middle one, so where's that gonna be?
5.
Yeah, does that make sense? Okay, yeah, so if this is the middle value, then the distance that the middle value is away from this x-coordinate is also how far the other x-coordinate has to be away, in the other direction though, right? So how could we think about that? There's a bunch of ways we could think about that. How do I always find how far apart 2 points are? Don't I just subtract, right? Well, I can just subtract in this case, can't I? If I want to just find the coordinates, if I want to know how far is 2 away from -1, I can just say 2 minus -1, right? And that's 3, so then I'm just going to add 3 to 2. Make sense? Okay. What about the y coordinates? We start at 7 and then we go to 4. So what do you think, Carrie? How far apart are those? If I start at 7 and I go to 4, what have I done? I subtracted 3, didn't I? Okay, good. So where do you think then the y coordinate of the other endpoint is going to be? Well, okay, no, you said you subtracted 3, right? We started at this endpoint and we subtracted 3 to get the middle y value. So what do I do again to get to the other endpoint? Yeah, so what do I get? 1, that's it. Right, subtract 3 from 4. Makes sense. Good. Okay. There's another way you could look at this, kind of more of an algebraic way, and that is you could take the average, the definition of an average, and you could plug in some values. Like for example here, if I know that the midpoint has to be the average of the 2 x values, well, what are the 2 x values? I could just call them -1 and x, right? I don't know what x is, but I need to find out. Whatever it is, -1 plus the other x value divided by 2 has to equal 2 because that's the x coordinate of the midpoint, right? And so that's another way to look at this. Then I could just solve for x. Now, what are the steps in order I'd have to do to solve for x there, to get the x by itself? What do I have to undo first? I gotta undo the division. How do I undo dividing by 2? Multiply by 2. So I multiply by 2 and that gets rid of the 2 on the bottom. I get a 4 on the other side. Next step. How do I get rid of -1? Add 1. And so I get 5, right? On this side, I know the average of the y values has to equal 4. Well, the first y value of one endpoint is 7. So 7 plus the other y value over 2, because I got to average them, must equal the middle y value of 4. Same algebra, isn't it? I multiply by 2 to get rid of the 2. Subtract 7. Now I got 1, right? Either way, I mean, those are both, I think, perfectly legitimate ways of thinking about how to find the other endpoint. Okay, last issue, angle bisector. So angle bisector is to segment bisector, you know, well, angle bisector is to angles like a segment bisector is to a segment. It's just going to be something that cuts the angle into 2 congruent pieces. So if I've got this big angle, then I could, for example, have a ray that splits it exactly in 2, and that ray, BD, would be the angle bisector. Okay, this is our way, remember, of showing congruence. Okay, so we'd say ray BD is an angle bisector of angle ABC. Okay, we can do the same kinds of stuff with that. Like, what if we know that, for example, if I know that the measure of angle EFG is 120 degrees, so this whole angle is 120. What is the measure of angle EFH? It's got to be 60, doesn't it? It's gotta be half of the big angle, right? So you got the idea. All right. Okay, an algebraic example. What if I had something like this? What if I know that this ray bisects the big angle, which I know because I've got those congruent symbols, right? So I know their measures must be equal. This is real similar. I just want you to see this so you can kind of draw the comparison between the kind of stuff we do with segments and the kind of stuff we do with angles. What do you think about this one? What can we do here?
X plus 4 equals 3x times 4.
Yeah, okay, so I can set those equal to each other, can't I? Right? Because I know that I've got an angle bisector, so the measure of this angle has to equal the measure of that angle. Set them equal, and just solve, right? Subtract the x to this side, add the 20 to that side. I get, what, 2x equals 60, so what's x? 30.
No, sorry.
30, close. So 30, and if I plug the 30 back in, I get 30 plus 40 is 70. 3 times 30 is 90 minus 20. Sure enough, it works, doesn't it? I get 70 in both cases. Does that thing look like it's drawn properly? If that's a 70-degree angle and that's a 70-degree angle, combined, the whole thing would be what? 140, and 90 degrees is a right angle, isn't it? So wouldn't it really be much bigger than that? Okay, important question. Does it matter? No, it doesn't make any difference. Never assume that drawings in geometry are to scale. Always assume that they're going to be distorted. All we really care about is the information that shows up in the drawings, right? Okay, that's it. So I'll let you get cruising. Why don't you come on up and grab the Chromebook. I will update grades so you guys can work on assignments. And tomorrow we'll do some constructions. A great way to finish the week. All right.